Hey guys, this is 6.2, so it's still carrying on in our linear relations and linear equations unit about graphs. And so this particular thing is extremely easy. It's something that you've done before in grade 7, even before that. It's just talking about reading graphs. So this teaching time should be pretty quick, and also this page should be extremely simple for you to execute. So basically the 6.1, which is patterns, is extremely important to finish. Homework this week is a really big deal. I'll be sending out some messages to make sure that's done, but this shouldn't take very much time if you haven't finished that, and you have to do this as well. So there's some interesting words in this unit, and the first word is interpolate. And so basically what that means is, so this word right here, it just means that you're looking at a graph and you're trying to find a spot on the graph and trying to figure out what how many things it points out to. And so it's just reading inside of the graph. You've done this before, just a fancy name. So, I just want to show you here that on a graph always, in this particular unit, that you're going to want to make sure that there's a title. Remember that this is the x-axis on the bottom here, that the y-axis runs across the top, and that coordinates are always with the x first and then the y second. All right, and so whenever we look at coordinates, so for instance right here, coordinates are 610, you want to start with this as your x-axis, and this is your y. So you start at 600, and what you theoretically need to do, and if I was on the board right now, I'd be using a ruler. Obviously, you can see how my graph looks like a masterpiece, and so yeah. But you would use a ruler from 600. You go straight up, and until you'd hit that line of this graph right here. So so you start with your x coordinate, and as soon as you hit the line, you stop. So we're starting at 600. We bam into that line, and then we're just going to go straight across with a ruler as well. It's going to point at a temperature there, and so we notice that at 600 altitude, the temperature should be approximately 10 degrees Celsius. So literally, this is what we're doing this particular chapter. We're going in, we're finding a coordinate, we're moving up to hit the line, and then we are moving over to the y-axis to see what it equals on this side. Super simple, nothing rocket scientist. When we talk about interpolating or looking inside of lines, you only can kind of do this when it makes sense to do so. For instance, like if the x-axis had, instead of altitude, we were talking about human beings, we can't actually have 5.4 people. So if you went up here from 600 and you went over and it was 10.1, well, we can't have 10.1 human beings. And so you can't interpolate on lines that the data just doesn't make sense for. You have to make sure that you're using things like altitude and temperature where you can be inside of the temperature, 3.5 degrees or 600.1 meters in the air. You can do that, but you can't do that with people. So interpolating only works when it makes sense, and you can't have part of a person, and you can't buy, go to the movie store and buy 1.6 parts of the movie, right? So it has to make sense. And so when we join the dots on a graph like this, it shows that data is something called continuous, which means it just goes up in a straight line. And when it's continuous like this, when a graph is in a straight line or when it's continuous, so I'm just going to put straight line here, then you are able to go in and interpolate if it makes sense. But I wanted to show you this graph right here. This graph is a graph that goes up, and then it goes down, and then it goes up again. And this is called a non-continuous graph. So non-continuous graphs are really unpredictable. And so you cannot predict or estimate any points on this line because you don't know where the next point is going to be. Is it going to go down, or is it going to go up, or is it going to go, where's it going to go? We don't know. So we can't make any estimates on a line or the graph is not continuous. And continuous means a straight line. So on a graph like this up here, you can make some estimates because it's a continuous graph. But when the line goes zigzaggy like this, it's a non-continuous graph and you cannot make any estimates. So you can't tell if this was a 4, at, I don't know, in the 4th stop, could you determine? Well, you don't know if you could, so you have to say no. And so here's some examples that we'll just go over real quick to make sure that you know how to do this particular unit here. And so this one says, this graph shows a plane's altitude. It lands, as it lands. The relationship between the altitude and time is approximately linear. So again, look at the line is in a straight line. So we already know it's a continuous graph. So what was the plane's approximate altitude at 50 seconds? You guys, literally, here's what you do. You find the time, and so I'm just going to make this a little bigger. So we're looking for 50 seconds. So you find the time, okay, it's down here, you go to 50 seconds. What you do, you put a little dot there. You're supposed to use a ruler, you go up to the line, bam, and then you go all the way across. And so what do you guys think that's approximately? I'm going to say that's a 9. So what's the plane's approximate altitude at 50 seconds? I'm going to say about 9 kilometers. Remembering that we have to use these units in the graph because that was what it was. So that's what I did. I found 50. I went straight up. I went straight across, and that was done. At what time was the plane's altitude approximately 11 kilometers? Okay, so now I take my pen and I go to 11 kilometers. This is the kilometer zone right here. This is 11 kilometers. I gotta go and move my pen all the way over to where I hit the line, bam, and then I'm gonna go straight down. And I'm looking at, I don't know, I'm going to say that's like 43 seconds. I don't know, something like that. And guys, when you're doing this in your textbook, just make sure that you know that like if you're 2 or 3 or 4 or whatever off, it's probably just because your line sucked and it just your eyes play tricks. I often have people on the test get really bad marks on it because they just do it by their eye. And for some reason, our eyes are really bad at actually determining where it stops. So if you can be drawing lines or if you can, do a really good job, just try to make your best guess there. But if you're off by a few, it's okay on this particular part because this is just us guessing. Is it appropriate to join the points with a straight line? So it doesn't make sense for us to join the points in a straight line here. So this is when we kind of have to take a look here at the graph and we say, okay, we're looking at time and altitude, which basically means how high the airplane's flying. So obviously when the airplane's on the ground, so at time at 0 seconds, so this is, okay, so at 100 seconds, it's coming into a landing. So it was high up and then it obviously came down to the runway here. And so, yeah, that makes sense. Is it appropriate to join the points? It looks like it came down in a very straight line. And so when it's in a straight line, we can say that the graph is continuous. And so, yeah, it's okay. It's okay to join the dots together. And when the dots go kind of like all over the place, that's when we say we don't join the dots together. So that's when we say it's not okay because there's no rhyme or reason. How do we know? But in this particular example, the line is straight, and because the line is straight, we can actually say, yeah, it makes sense to join the dots. We use this word extrapolate. Maybe you've seen it before. Extrapolating is using graphs to estimate a value beyond its given set of values. So guys, this is going to be a little bit tricky for you guys just at home. You're going to have to draw some of these graphs out to extend them, or in your textbook. Sometimes you have to just like get in there with a ruler and kind of draw really lightly on your textbook to solve these problems. But extrapolating means going beyond what the line was. So it's kind of asking for more data. It should only be used when it makes sense to have a line beyond the given values. So again, it's just using your common sense. It's just being able to see like, can I continue? So extrapolating means that the graph ends here, but you're just going to keep rolling and you're just going to keep drawing that line so that we can get values maybe out here. Does that make sense? So that's what extrapolating is just extending a line this way. So that's a very important word that we're going to look at here. So again, we're going to come into this question. The value of a computer decreases over time. The graph shows the value of the computer after it's bought. Say, after what approximate period of time does the computer have no value? So guys, this is, it's asking about time and when does it have 0 value? Well, 0's right here. So what you're going to do is you're going to take your pencil or your pen or whatever, not your pen in a textbook, but you're going to extend this line because it's a straight line. I can keep extending it all the way down. Okay, when it hits the line, you're going to put a little dot there because we're looking for when it has no value, which is 0. So it hit the line at 5 years. So my guess here is 5. Again, this is an approximation. So we're not looking for exact points. We're just looking for an approximate. When was the computer worth approximately $200? Okay, so this is my time where I go to $200. Okay, here's 200 right here. I need to extend my line all the way, hit the line there, and then I need to come straight down, and oh, there it is. I came down to the 4. So about 4 years, it was worth $200. Is it appropriate to join the points together with a straight line? Absolutely, yes. Why? Because the graph was continuous and it went straight. If the dots had been all over the place, then we would have said no. So guys, that's basically 6.2. That's how easy it is. There really isn't a lot more to say about it. You're going to be looking at a bunch of graphs and doing some estimations. I know that there's a few that, as far as I remember, that might feel a little weird, but overall I think the assignments are pretty clean, and like I said, it shouldn't take you very long. So please make sure that you finish 6.1. It's essential to this unit, and then come into this, and it should only take you a few minutes to finish the assignment.